Good morning, students. Continuing with the topic alkenes. Today we are going to discuss the chemical properties of alkene. We don't have all the chemical properties in our syllabus. Basically, we are going to focus on the addition reaction. And we know that addition reactions, basically they are typical reactions which are shown by the unsaturated organic compounds, that is alkenes and alkynes. Now, so this point has to be remembered that addition reactions are specifically shown by alkenes and alkynes. So here we are going to show or study the few of the addition reactions. Now, first of the addition reactions of hydrogen. Now, one thing must be coming to your mind, that why addition reactions are shown. Now, since the alkenes and alkynes, their tetravalency is not satisfied by hydrogen atoms, but their tetravalency is satisfied by the formation of a double or a triple bond, at least one double or a triple bond between the two carbons. So, the tetravalency is not by hydrogens. So, it means that once they have something to add on, so there is a possibility that the double bond can become a single bond after addition, or a triple bond can become a double bond, and then the double bond can become a single bond. So, this option is available with alkynes and alkenes. That is why they undergo addition reaction. Now, let us see here. Now, here they are showing you the addition of hydrogen gas, that is what we call hydrogenation. Addition of hydrogen is called hydrogenation, and here hydrogen gas is one molecule of hydrogen is being added to ethene, and this happens in the presence of a catalyst. That is why it is called as catalytic hydrogenation also. Now, since you know ethane is C2H6, but ethene is C2H4, so it means it has unsaturation. So now this 2H2, two atoms of a molecule of hydrogen, can add on and make it an alkane. So now the unsaturation is finished and now it has become saturated. So this is called addition reaction. So it means now in ethane, the tetravalency of each carbon is satisfied by hydrogens only. Tetravalency is satisfied by hydrogens only. So that is what is moving from unsaturation to saturation. Another example, we can also do addition of halogens. When halogens are added, then that is called as halogenation. Now, reaction with fluorine is explosive. That is why the compound formed is not stable. So, we don't study addition with fluorine. Chlorine, bromine and iodine, they can be added to the double bond at room temperature to form saturated dichloro, dibromo, diiodoethane. For example, this is the formula of ethene, and I hope you know that now this is the condensed formula, and in this molecule of chlorine is going to be added. So, here what happens, out of the two atoms, one goes to this carbon, equal distribution, and another atom goes to this carbon. So, we can see that this double bond is not required now, because the tetravalency has been, one of the valencies of this carbon has been satisfied by this chlorine. So, there is no requirement of a double bond here. So, now one chlorine, as I told you, one atom goes to each carbon. So, now this is, you can do numbering from any left to right, right to left. Now, if this is 1 and 2, now it is at number 1 we have addition of chlorine, and at 2 also we have. So, we call it 1, 2 dichloroethane. So, what is the name of this organic compound? The name of the organic compound is 1, 2 dichloroethane, because we have two chlorines here and we don't write chlorine, we write chloro. O, we suffix by O. So, that is why the name of this organic compound, that is the addition product. This is the addition product that is formed, is 1, 2 dichloroethane. Similarly, now let us add bromine, Br2. Similarly, one will go here to this carbon and another atom will go here to this carbon. So what do you get? You get a similar type of addition product but with a different functional group, and the name is 1,2 dibromoethane. Now this is a very important reaction. Now why it is important? Because it helps in identification that whether it is a saturated or unsaturated. Now I hope that by now it must be clear that only alkenes and alkynes can undergo addition reaction. So suppose if we have to distinguish between a single bond or a double bond, then this bromine solution can be it can be used very easily, and this bromine solution should be made in CCl4. It means it should be dissolved in CCl4. When bromine solution in CCl4 is taken, then initially it has a reddish brown color. In some books it's given orange, that is also acceptable. When we add this bromine solution in CCl4, that is reddish brown in color, to an alkene. Now what do we get? We get an observation. The reddish brown color of bromine disappears. Why? Because the Br2 is adding on to the double bond. So that is why now we will be getting colorless dibromoethane. So this is the test for unsaturation, that when bromine solution in CCl4 is added to an alkene, and remember this will happen with a triple bond also because they are also unsaturated. So when bromine solution is added to an alkene or an alkyne, the reddish brown color disappears and it becomes colorless solution. This is called the test for unsaturation. Now let us come to the addition of the next halogen, that is iodine. When iodine is added, so we get 1,2 diiodoethane. Now we get 1,2 diiodoethane. There is no requirement of this dash here. You can just omit it. No need to write. And in commonly it is called as ethylene iodide, because you know the common name of ethene is ethylene. What is the common name of ethene? Ethylene. So that is why the common name is ethylene iodide. Reaction with iodine is very slow, and the diiodoethane formed is unstable. Now once it is formed, this compound is not very stable, and after some time, since due to lack of stability, this product changes back to this. It reverts back. So it regenerates the ethene. So this addition of iodine does not give us a very stable product. So I hope in this video you must have understood that the ethenes can undergo addition reaction. They can go addition reaction with hydrogen, with halogens, not with fluorine, because it's explosive and the compound formed is not stable. Even with iodine, the product formed is not explosive, but it is unstable. Out of the two, bromine is very important because it gives us test for unsaturation. So this is all about the chemical properties of ethene. Thank you.